All right, I think we're going. Welcome to the linear functions unit. We are going to do what it says right there on the screen. We're going to learn how to convert our next equals now equations, which we learned about in our functions units, into slope-intercept equations. So, without a whole lot of further delay, here we go. And I know you guys like these full screen, so let's go full screen. There's a little extra thing there. All right. So, first of all, if we've given a table of data, can we get ourselves a slope-intercept equation? I think we can, can't we? If I could get a pen, we'd be feeling that much better. I don't know why the pens aren't working, but let's go blue. All right. So what we need to do is figure out, well, what's going on. We're adding 3, we're adding 3, we're adding 3, we're adding 3. So we get the pattern. We seem to be adding 3 as we go along, okay? So with the next now equation, which I'm not going to go into great delay, we do next equals now plus 3. And we're starting at, in this case, 3. So next equals now plus 3, starting at 3. That should be easy enough for us to remember. So as we move forward, what we're going to turn it into is the slope-intercept form. Slope-intercept equation. And I'm pretty sure you've seen this before. You've mentioned it on several occasions, but we're just going to spend a few seconds making sure we're all talking the same language. So when we're talking about the slope-intercept equation, we call it the slope-intercept equation because this number in front of the x represents the slope, and this number represents the y-intercept. And since the two pieces of information are in the equation, we decided to call it the slope-intercept equation. Because you get the slope, you get the intercept. The slope talks about the steepness of the line. So it's typically we talk about the rise over the run. Okay. The intercept is technically the value of y when x equals 0, but to a large extent it's like where the function crosses the y-axis. I need to go with I'm going to go specific. It's the value of y when x equals 0. For right now, that's what we're going to say. Okay? So slope, rise over run, talks about how steep it is, how fast it's growing, or getting bigger or smaller. This is kind of where it starts out at. So, I use the word start. So when we have my next now equation, which we got from here, next equals now plus 3, start at 3, we want to change it into a slope-intercept equation. We want it to be in this form, y equals mx plus b. Okay? And so what's happening into the next now equation, we're repeatedly adding 3 every time we get to the next step. Plus 3, plus 3, plus 3, plus 3. And if you remember, repeated addition, the shortcut way, the more efficient way to do repeated addition is to multiply. Okay, so this number that we're repeatedly adding becomes our multiplier of x. So this becomes 3x. And then the starting at value, as I said, the value of y when x equals 0, well, when x is 0, y is 3, which is our start at number, is my y-intercept. So this equation becomes y equals 3x plus 3. So we start with the table, we get our next now equation, we write, we roll. Okay? So generally speaking, if we have a next now equation, our next now equation is going to look like next equals now plus m, which is my slope, and then starts at b, my intercept. Okay, so if we can get a next now equation, whatever number's on the adding part, that's what's going to turn into my slope. Whatever number's the start at, that's what's going to turn into my intercept. Nice one. Okay, so y equals mx plus b. So this is a kind of important piece to carry along with us until we don't need it anymore. Maybe never. So again, let's do this one. Okay, boom, boom. For what's going on, constant rate of change, right? So next equals now plus 4. Plus 4, and we're going to start. And it's an add sign. It's an awful one, but nonetheless, we're going to start at 2, right? 2. And so my equation becomes y equals 4x plus 2. That's my slope. That's my intercept. I try to write really small. It doesn't like that, but we'll go with it. Okay? So y equals 4x plus 2. Now try this one. Why don't you try this one? Oh no, let's do this because it's slightly different. I don't want to get people confused. In this one, What's going on? How are we getting from one number to the next number? It looks like we're subtracting 2, right? Subtracting 2. So my next now equation, next, equals now minus 2. And where do we start? We start at 10. Equation-wise, y equals, what's my slope? The slope is, in this case, negative 2. Okay, x, and my starting at is 10. So my y equals, in slope-intercept form equation, y equals negative 2x plus 10. Okay? That's all there is to it. Okay? One more little thing that we must be sure that we're careful of. Okay, so as we go here, we're adding, what, 6 every time? And you always want to check a couple of layers just to make sure you don't get tricked or something like that. It's not a step function or some crazy thing or piecewise. So we're pretty good. We go next equals now plus 6. Starting at, and I hope as I'm writing starting at or start at, you're going, hey, wait, look, you can't just go 5, right? It's not the first one. Remember why the intercept or the starting value goes with when we go to 0, so we've got to go back to the 0, right? So if we're going plus 6 to get here, okay, what number did we start at if we added 6 to it and end up with 5? Or what's 5 minus 6 going in the other direction? Negative 1. So in this case, my start at is negative 1. So I always got to make sure that we're matching up with the 0. Okay, sometimes I'll try to trick you or someone will try to trick you. Now that we're trying to trick you, we're just trying to make sure you're paying attention. So y equals, there's my slope, 6, x, my intercept, minus 1. Okay, and we don't need to do plus minus 1 or anything like that. Just minus 1 is perfectly legitimate. So y equals 6x minus 1. That's my linear equation in slope-intercept form. Okay, so if I give you a linear equation in slope-intercept form, I would expect that you'd be able to quickly, even without a table, just write the next now equation. Oh, no, sorry. If I give you a next now equation, let's try that again. If I give you an x now equation, I would expect that you'd be able to write a slope-intercept equation, right? Okay, we'll do this one together, and I have a couple more that I'll leave for you to do. So if next equals now plus 5, that's my slope, that's my intercept, that's my equation. Boom. You try that one. Pause for a brief second so that you can do it, or you can pause yourself, I guess. Okay, so write me a y equals equation based on that. We'll talk about that in class. Okay. I think you can do this one as well. Y equals. Okay, so that's pretty good. You can pause. And then if I give you a slope-intercept equation, can you work backwards and get me the next now equation? Okay, I think you can. So next equals now plus the slope, right? My slope in this case is plus 3, and I'm starting at negative 4. The sign's important. Make sure we have that. Next equals now plus 3, starting at negative 4. Is that right? Okay. This one, don't let that fool you. It's just function notation that we learned about last time. Can you write an x now equation for this? Bet you can. I'm going to leave you with the next equals now part. And I'll even go so far as to write the start at part. Well, you have to write it anyway. And so take care of that for me, okay? And we'll look at that one again. And then finally, I think for today, we've got y equals negative 1 half x plus 3. So if we do this as an x now, don't let the fractions scare you. Halloween's over, no need to be scared of fractions. Next equals now, my slope in this case is negative 1 half, so now minus a half. Starting at 3. Okay, that's it, I think. It's a blank slide, isn't it? Yeah, so we should be able to convert easily from next now type equations to slope-intercept equations, which is my y equals mx plus b equations, slope-intercept. So we should be able to go in both directions, from next now to slope-intercept, from slope-intercept to next now, in one happy swoop. Okay? So, thanks for watching. I hope you learned something. Hope it made sense. Hope, well, we left it under 10 minutes. Good for us. So that's good for you, too. So, thanks for watching. See you tomorrow. If you have questions, you know to ask. Thanks. Bye.